G'day fellow flight simmers and random YouTubers. Well, today I feel compelled to make this video, and it's basically in response to a video I saw a couple of days ago, and I'll put a link in the description. And it highlights how VATSIM can give you, or flying on a virtual network or in a simulator, can give you a false sense of security in that you're thinking you're doing the right thing, but really you're not. Now this, Peter, if you're watching, this is by no means trying to put you down or anything, and I know we've had words before, but please don't take it as I'm trying to put you down. If anything, I'm just trying to highlight a few things from a teaching perspective. Hopefully it'll help others, and you never know, you might learn something from it and think, geez, I've been doing all those years, I've been doing this, and guess what? It's not quite the right thing. So and first of all, there's actually two main issues. The first one is actually the flight planning. Now, Peter flies from San Diego, he flies out to Santa Barbara, and he uses a very good tool to flight plan. And he's basically initially flies from San Diego, he goes over to Catalina, and then up to the Ventura VOR, and then over to Santa Barbara, which on the surface you think, oh, that's okay. Now the thing is, in the simulator, you can make it as real or as unreal as you want. Now the problem is, as you start to make it as real as possible, then it becomes a little bit more complex. And what do I actually mean by that? Well, if Peter hadn't gone online and basically just flew as he'd flight planned, it would all been hunky-dory, and he could have just flown outbound from the Mission Beach VOR over to San Catalina and straight up to Ventura and so on into Santa Barbara. But he went online, so now you're dealing with air traffic controllers. So now you add another level of complexity. So what's the complexity? Well, the thing is, the flight plan, and I remember Peter sitting on the tarmac for a while because his flight plan was initially rejected and he was offered an alternate flight plan. And then subsequent to that, well, an amazing dialogue happened, which I couldn't believe. And like I said, Peter, don't take this as, I'm hoping it's constructive criticism, if anything. The first thing is that he used Plan G to flight plan. Now, on the surface it looks okay, but it has a couple of shortcomings, or falls short in a couple of ways. For a VFR flight plan, it's fantastic. For IFR, it falls a little bit short. If you really want to do yourself justice, there you are, Peter. You need this, and you need this. It's a wonderful, wonderful tool. And why do you need this? Well, this has got a hell of a lot of information which you need to fly a particular route, especially for flying VOR. Okay, so that's the first thing. I think you've used the wrong tool. You may think, well, why? Not really, but I beg to differ. The whole purpose of the whole thing was to show how to fly VOR to VOR. which leads me on to the second point. Now I'll show you this, and once again, I hope don't take offence, Peter, because it's not my intention, but have a look at this. This is what happens. The air traffic controller offered him an alternate route, and if you plot this route on Sky Vector, basically offers him to go along the Victor 23 radial, right? Don't know if you can see that, but he's gone Oceania, Victor 23 to LAX on the Victor 29 to Ventura, Ventura 282 to Quang. Now, so he basically offered him this route up to Oceanside, the Victor 23 to Los Angeles, sorry, oh, sorry, oh, hang on, sorry, okay, so Victor 23 into Los Angeles, over Los Angeles on the Victor 29 to Ventura, and then Ventura, see that 282, he's offered him to, he wants him to go along, he wants him to track the Ventura radial outbound and then obviously into Santa Barbara, which is a reasonable, now I'll get to why he wants him to fly over Los Angeles in a minute, which is a reasonable flight plan. And looking at this, and being an ex-traffic controller, I was in the Air Force, and I've, you know, also I'm a C1 controller on night, and I've seen lots of flight plans and had to correct a lot of people, because one of the things a lot of people don't know is how to flight plan. Okay, so that is a reason. The air traffic controller knew exactly what he was doing. Unfortunately, Peter, I think, didn't quite understand, and he said this is the amazing part.
I would request VOR to VOR navigation today. Is that possible?
He says, I request VOR to VOR. Would that be possible? Well, Peter, that's exactly what this is. If a Victor airway connects one VOR to another VOR. That's why they're called Victor Airways. And that's what the air traffic controller wanted you to do. And now, it's quite obvious you know how to, I've saw all your video, and you know how to fly inbound, outbound on the radial. So it's not too hard, but there's a lot of work because you're going to be changing frequencies, and especially around here you're going to be busy. But that's very doable in the Cessna 172. I'll talk about that later. This little, see that little sort of thing there? I'll tell you what that's all about, which you won't see on Plan G, and that's very, very important. Well, actually, I'll tell you what it is now. I might as well get the theory out the way. That's telling you that you want flying outbound from the LAX VOR, and you're following the 276 radial. However, and I'm assuming LAX, this is a changeover point. In other words, when you get to 18 DME from Los Angeles, you switch over and you tune in the Ventura. So that there is very, very important, because not all VORs are created equal. Some are only good, they're called terminal, and they're, I think, memory serves me correctly, 20 odd miles and a certain altitude, and I don't know exactly, but they're different. Different VORs have different ranges, and they're good at different altitudes. Okay, and Peter also tried, see that there, that symbol there, that says it's a VOR with a DME capabilities, and that is a Vor TAC, which means it's VOR and TACAN. And TACAN is specifically used by the military. So you can see that that there is channel 8. They tuned in on channel 83 there, and the civilians use 113.6. So you can see the symbol is very different. And if it's a square, it means it's got just DME. And then there's others that don't have DME. That doesn't have DME, that one down there, Homeland. See, because it doesn't have a square around. It's got the hexagon shape, it doesn't have the square around it. So the air traffic controller knew, anyhow, getting back to the point, he knew exactly what he was doing. That was one point. So, Peter, I was quite amazed when you actually said that, because I thought, you know, with your experience, you would have known that that's what VORs are. And secondly, in regard to the flight plan, I'll actually show LAX better, actually. Sorry, Los Angeles. Let's not muck around here. Okay. You initially wanted to go, with your flight plan, you wanted to go to San Francisco and out to Catalina and then up this way. And like I said, with the simulator world, you can be as real as you want. Now, if you weren't online, you could have flown this, it wouldn't have been a problem. And but because you went online, there's a problem flying from Catalina out to Ventura, and it's to do with this little airport called Los Angeles, where there's a hell of a lot of traffic going in and out. And the last thing that air traffic controllers want to deal with is a Cessna going along this route at 6,000 feet when, for example, if inbound aircraft coming in and they have to try to separate you from any aircraft descending down to final, or if their aircraft are departing, the last thing they want to do is worry about separating them from you while they're upwind or departing Los Angeles. So to get you out of the way, they put you up at 6,000 over Los Angeles, and that gets you out of the way. So kudos to the air traffic controller. He knew exactly what he was doing. Unfortunately, Peter, I don't think quite understood that. And like I said, I was sort of gobsmacked, and I had to have a bit of a chuckle actually. Like I said, don't take it personally, Peter, please. You know, when he said I want to do VOR to VOR navigation, well, you know, that's exactly what this is all about. Okay, so enough of my carrying on. Now, let's talk about Plan G. Now, some stage during the video, I'm not sure when, Peter got a bit confused about what radio to tune in on, and he thought that these darker numbers, or this dark line, was something to do with the true track. Well, nothing could be further from the truth. And let me just show you this. Let's try to see if we can work. Let's consider, if I draw a line from point A to point B, and this is true north, and I measure that angle from there all around there, and let's say that's 320 degrees. My true course is 320 0 degrees. If there is no wind, then my true heading in relation to true north is 320 degrees. Let's just say this is, sorry, I'll get it in a minute, sorry about this. Do you think I know how to use paint? No. Okay, so anyhow, so assume that this is 320 and there is no wind. So your true course or your true heading is equal to your true course. Now let's assume you've got the wind coming from the right hand side, from the east. Now obviously your true heading is no longer equal to your true course, because you have to fly. If I was to fly from point A to point B and I've got wind, obviously you're going to be pushed over to the left, so you have to account for that wind. Okay, so what you have to do is then you have to compensate for that wind trying to push you to the left. You have to head your aircraft to the right of that true course line. So you have to basically head your aircraft that way. Like I said, who knows how to work paint? Not me. And this is part of what they call vector analysis, and you can draw these to scale when you do in the real world. When you're doing your pilot or dead reckoning is what they call. You actually have to do this on the chart and work out all your, or what they call your correction angle. But anyhow, I'm jumping ahead of myself. So you have to basically head your aircraft into the wind to compensate the fact that that wind is going to push you over to the left. Okay, and then that wind vector is that way. So it forms a triangle. Now the angle between that heading there, or that angle, or the angle that is formed between that line and that line, is called the wind correction angle. So if you take your true course and you add your wind correction angle, because you're going further towards 360 degrees, if you know what I'm trying to say. Actually, I haven't done that very well, but you have to add. If the wind was going the other way, you'd have to subtract. And I hope that makes sense. Actually, let me do this a little bit better, because I can see that people can. Okay, so let's say I draw a line on the map, and let's say it's 310 degrees. We measure from true north, we measure around there, it's 310 degrees. And now the wind's coming from the right, so we have to compensate for that wind. So we now have to add, we have to basically draw a line like that. And the angle between that line and that line is what they call wind correction angle. And because let's say if that's let's say 310, then obviously this is going to be more, because there's 360. So let's say if that's 310, that's 320. So your true course plus or minus your wind correction angle gives you your true heading. But if I was to fly this, I would never get to my destination, because we have a thing called magnetic north. And magnetic north depends on where you are in the world. You can either be out there or could be out there. And the difference between your magnetic north and your true north is called your variation. So to your true heading, you either add or subtract your magnetic variation to give you your magnetic heading. And your magnetic heading is what you fly with. Now, let's have a look. This is in the real world, and assume this is all real world weather. If you do the navlog of this, shows you very clearly basically what. So from San Francisco to Oceanside, the wind is coming from 170 degrees at 4 knots. So basically coming from the south, and you're following north, so you can almost say that there is no, because you're going to, that 171, the wind coming 171 degrees, 171 knots at 4 degrees is basically from the, so you basically got, there is no correction angle, and you can see that there, see the wind correction angle is 0 degrees. So your track from San Diego to Oceanside, your track, which is your true course, that's just another word for true course, and because there's no correction angle, your track equals your true heading, right? But this is where your variation comes in. Now, where do we get this 11 degrees? Oh, it's here. Actually, I'm a bit confused about this myself, because see this magenta line there? That's 12. See, there's a negative 12 degrees, and there's another one over here, 11.5 degrees. Our flight is over here, so if anything, I would have thought that would have been negative 12, which puts us on a magnetic heading of 328. So if we want to fly this course, if we want to fly this, we're going 328, and that's what Sky Vector shows us. This shows you our magnetic heading. Okay, so hopefully that clears up, because one of the guys asked him, said, Pete, can you just, tell us what the difference between track is, true heading, magnetic heading. So that's and that comes from just basic navigation. And in this, like I said before, the simulator world, you can make it as easy or as hard as you want, or realistic or as unrealistic as you want. The more you go towards realism, then obviously it gets harder, and you have to know a lot more. And believe me, I tell you, as an air traffic controller, as a C1 controller, I've seen the young kids, and they buy their 737 and they flight plan from Sydney to Melbourne, have no idea, and in their route they put direct, and and that's, yeah, well, anyhow, getting off the topic, let's not go there. So yeah, so that's I think it was, what was his name, Gus, or whatever his name was. So hopefully I've cleared that up. So I think they're basically the major issues that sort of concerned me at the time. And then there was another one, but I'll show you that when I get up in the air. Okay, so let's see if we can get up in the air and get going. Okay, so, and I hate doing this, but I'm going to give it the old auto start. I just move these away, out the way. I hate that effect. Looks crappy. And now this is not a tutorial on how to fly a Cessna 172. There are people out there who are fantastic. The two that I really highly regard is a guy called Country Flyboy, and there's another guy called Sim CFI. They really know their stuff. And I know that Country Flyboy has actually got his pilot's license, and they're the people you want to listen to. People have been there and done that, rather than people that, think they know what's going on. So this is not, and I hate doing this but I'm going to use the old Control E. Now, okay, so let's. Oh, and by the way, be careful when you've got different charts here. Now, what's the difference between the en route chart and the world high chart? Well, the en route chart is for if you're flying below 18,000, flight level 180, and anything above you use the world high chart. So if you're a jet plane, see here you can see the difference already. You can see that if I'm a Cessna, I can fly that way, and if I'm the jet, well, there is no. I'm going to be flying up that way. So your low en route charts are for anything below flight level 180. Okay, so what's our plan? Well, what we're going to do, we're going to simulate what Peter did, and we're going to take off 27. We're going to do a right turn. I think his air traffic controller says turn right 290, climb to 6,000, which was his planned altitude. And then he said track to the Oceanside VOR. And then Peter does something which I'll explain, which hopefully people realise what the difference is, or what actually the error in it. So let's now, first thing, to fly on that Victor 23 we have to fly outbound on this 326 radial. So first thing we want to do is make sure 17.8, and we want to, oh, by the way, before I go on, this is called the OBS, Omni Bearing Selector, which changes what radial you want to fly to or from. Now at the moment, and also you've got a little flag here that goes, it's either to, or when it points the other way it's called from. Now that's showing it's to, and that stands to reason, because if you see here, we're down here somewhere and we're going, and it's to, that 326 is to that radial. Actually you're almost in line with it, and you'll see later on when we take off there'll be a split second when we actually cross that. If I was to extend that line, see the 326 radial goes from there, let's say, to there, but if you extend it, it goes, at one point we actually cross that radial, and then you'll see the CDI, the course deviation indicator, it'll start moving to the right, and it means that 326 radial is to the right, which Peter did mention and which he did get right. Okay, so let's just say 6,000, everything's there, 115 decimal ocean side. Okay, I just check to make sure my rudder pedals are working. And of course my call sign is Aussie. What do you think it would be called? Yeah, I could imagine the comments there. November Foxtrot India. No effing idea. Yeah, okay, rightio. Okay, so let's get ourselves. Now, like I said, this is not about how to be a pilot or how to fly the Cessna. It's purely to show you how to intercept and track a radial outbound. There's three things you should know. First of all, how to track outbound on a radial. That's one. Two is how to track inbound on a radial. And you think, well, what's the difference? Well, there's a little bit of difference. And three, how to track direct. If you don't know, if you're out in the middle of nowhere how to track direct to a VOR, and that's important because once we get up in there, I'll show you why. Okay. Oops, I forgot to bad boy. Okay, let's chuck it into okay, that'll reduce my workload so I can wrap it on again. Okay, so I remember now what we've done this is because assume that we were given maintain runway heading, climb to 6,000, whatever, or let's say maintain runway heading. Now at a certain point we get handed off to approach, and in this case wait till we get to about 1,500. Let's just enjoy the view, eh? Before I talk to on my next point that I want to talk about. I love the Orbeck scenery. Okay, so let's say I think in the video Peter gets an instruction to he says he contacts circle approach, and he says turn right heading 290, climb maintain 6,000. Okay, so got in heading mode, hunky dory. We see that flag is still indicating 2, means in other words we haven't passed, but the VOR. So let's say we go 290. Oh, I forgot to. It's always a good idea, no? Okay, this is for a check. This is to check up on different things. So we're heading 290. And I think very close to about 3,000. The air traffic controller says, and this is very important, I'll just kill that sound because at 3,000 the air traffic controller says words to the effect. He says this, he says November 404 Foxtrot Romeo, or something like that, whatever his call sign, Peter's call sign was. He says track direct to the Oceania VOR, resume mode navigation. Or resume, we say it in this in Australia we say it the other way around, I think. It's resume mode navigation, track direct to the Oceania VOR. Okay, actually. So what Peter does, actually I'll pause that there. I'll show you on what Peter does. He basically turns around and he intercepts that VOR, that radial, and then flies up to Oceania. And you say, well, what's wrong with that? Well, that's not what the controller meant. It means what the controller meant by that. From that position there, he doesn't want you to intercept that VOR radial, because he could have someone flying out there, or he might have a guy inbound. So he wants to keep you separated from some guy. Might be a guy inbound or whatever. So he says track direct. It's very important. From this position, you track direct to the Oceania VOR. That's what he meant to say. Not intercept and track outbound on the 326 radial. He said track direct to the Oceania VOR. Okay. So how do we do that? Okay. So first, I'll unpause it. We got the Oceania VOR dialed in. And you see it's the flag goes to. So now, how do we go to Oceania? Well, what we need to do is we need to turn this OBS needle until that CDI centers to find out what radial we're actually on. And it's 337. So what we do is we actually have to turn to 337. And it's going a bit to our right, so oh great. And we hit nav to make life easier, because now it'll adjust. You'll see the aircraft wobble a bit until it sort of finds it. There it goes. See, now it's adjusting itself to get onto that 337 radial. Now we are flying direct to Oceania. Now if we look at 337 radial, 37 radial, say, I don't know, 60 miles, a bit excessive, but I know. And look at that. We're tracking now. We're not intercepting that radial. We're tracking direct to Oceania. Okay. So you can see that we're going to end up tracking direct to Oceania. And that's what the air traffic controller wanted Peter to do. But, okay, so that's number one. However, what we're going to do is we're going to intercept the 326 radial. So we'll just put this in heading mode. We're going to flip this back over to and we're going to okay, now let me just stop it there. You ask now, an obvious question would be, well, what angle do we intercept, or what would be a great angle to intercept the 326 radial? And then, yeah, what would be a great angle? Well, the actual CDI gives you an indication. If you have a look here, and as Peter pointed out, that's the aircraft, and our 326 radial, I think, yeah, is to our right. So we're not concerned with anything on this side of that CDI. What concerns us is, or what's a good marker for us, is on what this side. This part here gives us a great indication of what heading to take up to intercept the 326. And normally you'd like to intercept a 30-degree interception or intercept, because it's like when you're intercepting the ILS, it's a great angle and it gives you a nice steady, it doesn't give you such an abrupt angle of what's the right word, it doesn't, you're not going directly, it doesn't give you such an abrupt interception to that radial. It's a nice smooth transition, as you'll see, and you normally look for 30 degrees. So if I wanted to intercept a 326 radial, I'd be turning it, my heading bug, to north, which I have done here. Now I could turn it to 030 degrees, but what's going to happen is, because I'm intercepting at such a acute angle, is that this CDI is going to move really, really quickly. But if I intercept it at a more shallower angle, that's what the phrase I was looking for, this is going to move across nice and slow, and then as this moves across and centers, I'm going to now start moving my heading bug, my heading, to reflect 326. And I'll show you what I mean. I'll just make it a little bit more. So, like I said, just 30 degrees is a nice intercept angle to intercept that 326 radial. Or a bit of, oh geez, a bit of turbulence there. Now, assuming we're IFR, so we really need to be looking at these, sorry about that, I don't know, I've got FSU IPC, yeah, okay, maybe it's crashing. Oh, bit of turbulence going on there. Now we're waiting for that needle to start to move. And this is the secret to, people think, well, how do I intercept it? And they sort of have a guess. But like I said, because it's to our right, we're only, this area here gives us a clue of what angle. And like I said, if you can sort of intercept about 30 degrees, so if you intercept the 30, if you add 30 degrees to 330, you get 360, which is your north. Okay, nothing happening yet. There it goes. Now it's starting to move. Now we gently start to move our heading towards that 326 heading. Now we just gently, because 326 is down there somewhere, so we don't want to do it all in one go. We just want to do it nice and gentle, because as I'm turning towards the heading of 326, this moves a lot slower. If I didn't move, if I started moving now, it'd just be too abrupt. So I'm just gently moving it I've got about 30 degrees to go, you can see that. Just gently moving, just slowly making a turn. Now, 1 dot. These see the little dots there. So I'm 1 dot away, so I should have been a little bit more. Okay, 326, and I'm spot on. Hit nav to make my life easier, to keep us on that. Now, the proof will be in the pudding. Let's go to Plan G. This is what I like about Plan G. You can't do this in Sky Vector. There it is. And I know I'm on that Victor 23 because see Carif, if I go to Sky Vector, there's Carif there and it's on the Victor 23. So I'm tracking directly and I'm tracking. So does it, everything matches up. You can see that I'm tracking from the VOR along the 326 radial. So I'm now flying the airways, Peter, and not VOR. Well, I'm going VOR to VOR and on the airway. And that's what VOR flying is. You're flying on the airway. So I don't know how you got confused between VOR and VOR and what else, what other. The thing got confused. I don't understand why you got confused, because you went from Mission Beach and you wanted to fly that dark line rather than the airway, which, like I said, that's what VOR flying is. You're flying along that airway. That's what the Victor Airways are. Okay, so now also from the DME, because we've got this slave to our Radio 1, and we're 15.8. It's another thing too, charts. See that 16, so we're nearly approaching Carif. And if we look at and there it is there, we are approaching Carif. So it all matches up, all the information. Now, let's say I wanted to track to Oceanside. And let me just, I need to pause this because I may now, where are we? Yep. Now let's say we're down here at Carif, and now we want to switch over because we want to use this VOR now because we want to track inbound, and then as we get close to it, then we want to track outbound on that 301 radial and go along this Victor Airway, which we can do. Sorry to labour the point, Peter. No, I'm only having to go, mate. No, I'm not really. But so now also another thing too, which, and I could go on all day about charts, just charts alone, but that there tells us minimum en route altitude. So it's a great indication that I should be at least 4,000 feet to have a 1,000 foot clearance between the highest obstacles or mountains. And also this tells us from that, see that 4.6 there? That tells us that's the distance between one VOR and another VOR. Okay, so that's important information, and this tells you, of course, from Oceania to Kelps at 7. And yeah, so all this information and all that, no, let's not get into it, otherwise I'll end up going for hours. I want to try to keep this video down to about, yeah, we're almost 49 minutes now, so So, okay, so we want to track inbound to that. So, we tune our VOR to the ocean side, which is 115.3, and we turn our omni bearing selector to watt radial. You see here 145. Now, a radial, and if you read anything about radials emanate from a VOR. In other words, that 145 is that radial down there. But we want to go to the VOR, so we don't want to track that 145 coming that way down. We want to track the reciprocal of 145. And if my math is correct, if I had 180 to 145, that's 325, which is almost the same as 326. But to be pedantic, that's what we need to do. We need to switch over to the ocean side, turn the OBS to 325, and let's just see what happens. So first of all, we're in nav mode, so just we can hit heading select and it'll stay. Now see that little, it went to 3, sorry, it went 2, so we know we're going to, I hate that. Now we turn our OBS to 325, spot on, and we hit nav. Now we're going to the ocean side, which is 115.3. And now it's just, now let's see. Yep. Looks like we're tracking it to the ocean side VOR. Now, what I like about Plan G, like I said, don't get me wrong, it's not, but I don't think it's an appropriate tool to plan IFR. And I think that's what really messed Peter up. He was looking at all these headings and all that, which, like I said, it's okay. You could have, this could have been all right if you were offline, and you know, you could have just flown those headings and it would have been fine. But being on BATSIM, where they require you to fly on the airways, and which is what VOR flight is anyhow. Sorry, probably the 18th time I've mentioned that, but yeah. So now, part of being a decent pilot, staying ahead of the aircraft, you always hear that. And also when I was doing my air traffic control in, God knows how many years ago, my training officer always said, what do you expect to happen next? Don't just sit there looking fat, dumb and happy. What do you expect? So you've got a guy lined up at the holding point, you've got a guy on final. What do you expect to happen next? Or who do you expect, or what do you expect the guy at the holding point to say, and what do you expect to do with this guy on final, and who you're going to clear, or who you're going to talk to first, and all these scenarios going in your head, so you're ahead of the game. Okay. Well, this is what I intend to do. We know we're flying 325 radial inbound to Oceanside. Now, when I get to about a mile from Oceanside, and I know that from my DME reading, I'll put the aircraft into heading mode, so just keep flying that heading, and I'll turn the OBS to 301, right, and then adjust my heading accordingly to match the 301, and then hit nav mode and then let it fly outbound on the 301 radial. Okay, so that basically, you have to sort of have that internalized basically to memory. You're staying ahead of the aircraft. Low fuel. So down here we can see we've got 5.3 miles to the ocean side. Let's see. Oh yeah, interesting. I don't think we're going to get to Santa Barbara today. Like I said, this wasn't a a tutorial on how to fly. It's always a good idea to have sufficient fuel for your flight. But I think basically we're getting up to about 54 minutes. I'll cover this point and then I'll probably stop the video, because basically it's repetition of those concepts all the way. And like I said, it's the same when you get up to here. What's the Los Alamos or whatever it is. Once again, you're tuning the 180 on that. You're tuning the 300 radial inbound, and then you're tuning the 272 radial outbound, and then there's a bit of work there over LAX, and then once again. Now this was the critical point, Sadie. This is the changeover point, because I guarantee you, if we looked at LAX, 2.8. Let's. I'll talk about that later. Let's just stay focused on this. Okay, so $301. Okay. So I'm two miles away from Oceanside. What base is that? Okay, 1.2, so 301. So I'll hit heading. I'll turn this to 301. Now I need to fly around about 330. Whoop. There it is there. Well, that moved really quick. Okay, let's make sure that's it. Now we want to fly basically west to intercept that radar. There it comes, it's coming across. It's actually coming across quite quickly. Now it's gonna do a right turn here. It's trying to, because it's a bit to our right. See, there it is. It's gonna, the autopilot corrects itself. And it's gonna try to go on the 301. There it goes. This is really good, interesting trying to do this manually. It's magic. This is why I love flying in Cessnas. That's why I hate flying jets, because try doing this manually. And plus, real world weather. It's great fun. Okay, so now we're on the 301 radial outbound from Oceanside. We've still got that. Always watch, like I said, stay ahead of the aircraft. So basically that looks okay. Now does plan G. Now, don't forget, we're on the airway. We're not flying that, we're on the airway. So Kelps is on the airway, and there it is there. And at 7 DME, right, we reach Kelps. So we're 3.9. And that's basically how you fly the airways and how you basically fly VOR or VOR navigation. I know that happened a bit too quick, that, and hopefully you understood what I did at this point here. Basically, I should have started turning a little bit soon, about 1.5 miles, and I would have had the 301 on my right, and then I would have turned a little bit towards, I don't know, 330 to intercept 301, and that all happened a little bit too quick. But I hope you get the general idea, and you can see on Plan G I'm tracking that beautifully, as the air traffic controller wanted. Okay, I think I better wrap this up. It's coming up to 1 hour, so I hope that clears it up for a lot of people. Once again, Peter, if you do get offended, well, I'm very sorry. I don't mean to do that at all. I just hope that basically maybe broadens your knowledge. Don't forget, I've got a lot of time for people who actually try to make videos and try to help people, so you do that, and that's a big plus for me, unlike some people. And we all know people who fly in Australia. This guy makes, and he makes videos, but he doesn't explain anything. And his first part of his name is musical. That's why I. Anyhow, enough of the bagging. I'm done. Any comments, leave them down below. I'll try. Anybody wants to, any other, if they want me to make another video on whatever, VOR approaches, NDB, tracking to an NDB, or whatever, I'll see what I can do, because like I say, I love doing this. I do a lot of reading, and I make sure that, I try to do the right thing, and plus my ATC background and knowledge, hopefully I've taught you all something today, and till next time, see you later.